welcome back to our channel, The Classroom. Today we are back with another chapter of class 8 chemistry, that is physical and chemical changes. If not in the second chapter, maybe in the third or fourth chapter of your book you can find this. I hope you have some knowledge about physical and chemical changes, since you have already, I think, have read about a bit of it in class 6 and 7. So directly coming to one particular point that is written on the board, that is changes. What are changes? Changes are some situations which keep on altering, maybe within a period of time or maybe regularly. Okay, so that is what is a change. It is particularly a natural phenomenon which is not always within our control. Now some changes do alter at a period, and some changes do not even alter itself back to its original form. Okay, so like for examples, you can take for you can see the switchboard behind me, right? Now switching on and off a switch can turn on the fan or switch off the fan. Then suppose the season changes. Now it's a month of June, right? So you can see that maybe every evening or maybe 1 or 2 days later, you can see there is a rainfall, there is a downpour, right? So these are, but in the other month, like we were continuing during the lockdown days, the first 10 days, that is in March, you would have seen that there were no rainfalls that time. But now there is a bit of rainfall that is coming every evening, maybe because of the change of season. So change of season is also one type of change. We cooking the foods, or mothers making food for us, right? The raw vegetables are getting cooked, okay, or boiled. These all are within the changes. So we have classified these changes within many categories. Like one, we have slow and fast change. Second, we have periodic and non-periodic changes. Third, we have natural and man-made changes. And the fourth that we have is reversible and irreversible changes. Now, these all categories of changes are already placed in these two particular changes overall, that is physical and chemical changes. Now let's start with what is slow and fast change. Which changes or which examples are actually considered as slow and fast changes? Like for example, you can let's get started with the this definitions first, then let's come to the examples. A slow change is a change which takes a long duration of time to get completed. That is, it takes a long time to finish. For example, you can take the example of rusting of iron. If you keep that outside somewhere or maybe open, okay, particularly a metal especially, okay, which has an property of iron especially. So these particular metals, whenever are kept outside, that is, it gets the moisture, it gets the sun's heat, okay, as well as the wind, the humidity, everything, or the water vapors, it forms a layer above its surface. This particular layer can be removed, but is hard to remove normally. Okay, you need many type of solutions or maybe some reactions to be done. Only then these coatings can be removed. Now this particular natural coating which occurs over a iron or metal, these are known as rusting or rusting of iron. Now rusting of iron is obviously not taking place within one single day. It takes few months, few weeks, or maybe even a year to get that particular coating over it. So that is what is rusting of iron, which is obviously a slow change. Now next, coming to the fast change. What is a fast change? A fast change is a change which occurs very fast. That is in a very short duration of time. Okay, like I'm switching on the fan. It just takes a millisecond to get the fan to get switched on, right? Or maybe I'm glowing a bulb. So it just takes some few seconds of time to get it switched on, right? These examples obviously, as you can see, just takes just a second while to get completed. So these are fast changes. Okay. Next, natural and man-made changes. Now what are natural changes? Natural changes are the changes which is brought about naturally. Human beings don't have any particular emphasis on that particular change. Those are usually been adapted by the nature. Like further, you can just say like the change of weather, okay, that is a natural phenomenon. We don't have, like suppose today now in the afternoon it is very cloudy, okay, just another while, suppose after 1 hour or 2 hour, suddenly you can see a sudden change in the weather that it has become full sunny. So this is particularly a natural change. Again, if I talk about a man-made change, you can take for the example that is the one change which is brought about by human beings, okay. So, or like we make the changes, like for example cooking of vegetables, okay, or cooking of food, that is a man-made change. It is we who cook it. It's not someone else or some, like the nature that is cooking the food for us, no, okay. So obviously it is a man-made change. Natural change, you can another take for example the ripening of the fruits, okay, that is also a natural change which is not done by man. Next, now coming back to reversible and irreversible change. The changes which takes place or which alters itself after giving a particular condition are called reversible changes. Now reversible changes, I'll give you a best example so that you can understand very easily. That is, suppose you are taking an ice cube, right? That gets, if you keep it under a warm condition, you will see, or just at a normal temperature, you will see that it gets changed to water. But again water, if you keep that in the freezer, you will see that it has got freeze to ice. So this phenomenon of change of ice to water and then again water to ice is a reversible process. Okay. Next, if I set aside the conditions, okay, that is even after, like you are going for a change but that change will not come back to its own state, will not come back to its own state, that is a irreversible change. As for example, burning of a paper. When you burn a paper, you will see at last only ashes are left. So that is a irreversible change. Once you burn a paper, that paper will not be intact in that particular way, it will get converted to ash. But these ashes will never be getting converted to paper anymore. So one which cannot come back to its original state, these changes are known as irreversible changes. Next again, coming to periodic and non-periodic changes. Now what are periodic changes? Periodic changes are one which occurs at a particular interval of time. Like suppose the change of the seasons, winter, autumn, then summer season, whichever is coming, or the spring season, whichever is coming. It's obviously you will know that there is a particular like a number of months after which the next season comes. Like just during the March, April, May, we had the summer season. Right now, from June, July, August, we will have the particular monsoon season. So this particular months after which, one after the other, there is a particular period of time after which a season changes. That is a completely periodic change. Okay? And if you talk about take for example about the earthquakes or the flood, okay, or maybe some epidemic that is taking place. This is obviously a pandemic, the COVID-19, but if you take these examples, okay, or a landslide, these all are non-periodic because you don't know at what time that is particularly going to come. The tsunami, okay, so these all are examples of non-periodic changes because you don't know at what particular time, or like every after 3 months it's going to occur, or like every after 10 months it's going to occur. So there is no particular time for these earthquakes or landslides to occur. So particularly these changes or these examples are considered to be as your non-periodic changes, right? Next, now for all the classifications of changes that we have already discussed, now these particular changes can be put under physical and chemical changes, right? Now let's study about both the changes now, physical and chemical changes. The first point that I have mentioned over here is no new substances are formed. As you can see, suppose let's take example and put up these points because it will be very easy for you to understand. So when it is said no new substances are formed, so just take for example ice getting changed to water and then again water getting changed to ice again. So you can see there is no particular one like change that is taking place, and you are getting a particular change or a particular answer for it, right? Here one product or one particular substance is getting changed to the other, that product that is formed, okay, is again getting back to its original state. So there is no new substance that is formed in this particular physical change. But for your chemical change, if you take for example the burning of the paper, burning of paper produces ash. So ash is again a new substance that is formed, okay, because paper was something which was like can be used. Ash is something which is just a dust, right? So that is a new change has been formed, and from this particular change or like the substance which has been formed, we cannot get back to its original state. So that is a new substance is formed. Next, coming back to no change of mass, taking the example of a burning of a candle. Now if you burn a candle, you will see wax are getting collected, right? Now you can weigh the candle and see what its mass is, okay, or what its weight is. And again you can take the wax and measure it, okay. You will see that both the thing, that is the wax as well as the candle, has the same weight or has the same mass. So that means there is no change of mass, it remains the same, right? Next, change of mass of original substance. Now here, if we consider the example of suppose magnesium, okay, I can write the equation over here, that is suppose Mg plus O2 is giving you 2 MgO, right? So here there are 2 magnesium, I am writing here 2 magnesium. So 2 Mg plus O2 is giving you 2 MgO. Now here this particular equation, you can see here is 2 mass of or 2 in number of magnesium and 2 in number of oxygen. It is combining to form 2 MgO, right? You can simply calculate 2 plus 1, there is 3, and here there is 2. So there is a slight change in the mass, where you can also add to it, maybe it is in the form of heat that is liberated, okay. But right now you can see there is a change in the mass. Here there were 3 in numbers, here there is 2 in number, okay. Next, coming to temporary and reversible change. As we have already done this, that what is a temporary change and what is a reversible change. This is a temporary because you can obviously, you have understood by the definition that it comes back to its original state, whichever substance is formed. And here reversible, obviously temporary and reversible both are almost carrying the same examples which you can tally it from here. Okay, next, permanent and irreversible change. As you know, this particular example of the paper getting burnt to ashes is a permanent change because ashes cannot be converted back to paper. So obviously that is permanent as well as irreversible. It cannot be converted back to its original state. So here comes permanent and irreversible. The last point that I have written is no gain or loss of energy. Now, if we are taking the ice takes up heat, okay, some amount of heat and getting converted to water. Again, water while converting back to ice will leave or will just leave out that particular same amount of energy. So obviously you can understand there is no extra gain or extra loss of any energy. Whatever amount was taken up by ice to get converted to water, the same amount of energy or the heat is again liberated out to get converted to your ice. So this is how there is no change of energy taking place. Next, if you consider for chemical changes, there is a change of energy, okay. Like there is some energy which takes up, like for burning of this paper, okay, whenever you are burning that paper, that is getting burnt to ashes. It needs some amount of energy, some amount of heat to get burned up. But this particular ash, okay, will not obviously get converted to paper. Now, since it's not getting back to paper, the amount of heat that this ash is liberating is in the form of either that is heat or light. Light we don't have because light only that much portion we have, that is when it is burning to ashes, okay. because it is a fire which makes it burn. So that particular energy is liberated out in the form of heat. Okay, so obviously energy is exchanged, right? I hope I'm very clear with the examples that you have understood. This particular example was just given to show that there is a change of the mass. Okay, here it is 2:1, that is total is 3 in mass, and here you are having 2. So this is just example of this particular point. Okay, I hope this chapter is very easy to understand. With especially it is my request to you or advice to you that whenever you are writing any definitions in this particular chapter, or you are putting up any point to explain, if you don't have any other things, any words, it's better go for examples. Give the examples, write it down and just explain that point. It will be far more easy and scoring even. Okay, the best thing is put examples just to explain these particular points. Okay, I hope I'm very clear with you with this particular chapter. If you do have any problem in this chapter, please do comment. And yes, if you have liked this video, please like, share and subscribe. We are going to come up with many other chapters of chemistry, physics, maths. Even you have seen that we have started with computer application of class 9 and 10 too. So please press the bell icon after you have subscribed so that you get the notifications. Thank you and have a good day.